Hi everyone, welcome to a new video. Today we'll be talking about how to find a quadratic equation given its roots or zeros. So in this video, I'm gonna first start with a simple example to illustrate the general approach to find the quadratic equation, and then we'll derive the general formula that you can use it to quickly find the quadratic equation, and then we'll use this general formula to solve different examples that illustrate different cases for the use of the general formula. So let's get started. Okay, so first we'll start with an example to illustrate the general method to find the roots. So here we have two roots, 2 and minus 3. So what we know is the following, that x is equal to 2 or x is equal to minus 3. These are the roots. Then from this, we can conclude that if we move this 2 to this side, we'll have x minus 2 equal to 0, or if we move this to this side, the minus become plus. So we'll get x plus 3 equal to 0. So we have two factors that give us 0. What this means that if we multiply these together, we should have 0 also, because it's either this 0 or this 0. So one of them will make this expression equal to 0. Actually, if you remember how we factorize quadratic equation, you will notice that typically we start with quadratic equation and then we reach two factors. And from this, we conclude that one of them should be 0 and then we get the root. So it's like we're actually going in the reverse way. Now, what we should do is simply to expand this. So I'm going to multiply the x with x and x with 3. So this will give me x times x squared. X times 3, this will give you 3x. Then we multiply the other term, minus 2 with x, and also minus 2 times 3. So this will give you minus 2 times x, that is minus 2x, and minus 2 times 3, that give us minus 6 equal to 0. Now it's a matter of simplifying. So this will give us x squared, 3x minus 2x, that is 1x minus 6 equal to 0. So this is actually our quadratic equation. So this is the solution to the problem. Now you can see that the approach is very straightforward. So let's apply this for a general case. Say that the roots we have are R1 and R2. So we're gonna follow the same steps. Our roots are x equal to R1 or x equal to R2. And again, I can move R1 to the left, so this will give us x minus R1 equal to 0 or x minus R2 equal to 0. If I multiply these, then we'll get also 0 since one of them is 0. So we'll get 0 for the product. We'll do the same thing now, we'll expand. So I'm going to multiply the x with x and with R2. So we'll get x times x squared, x times R2, that will give us R2x. Then let's multiply R1 with x and with R2. So minus R1 times x give us minus R1x. And then minus R1 times minus R1, minus times minus give you plus. And then you will have R1 times R2 equal to 0. And with little simplification, we can see that here we have x as a common term. So then I can have minus here R1, here R2. So we'll add them. Notice we have plus here because I took the negative to the outside. So I took negative as a common because we have negative here and negative here. So if we take them as a common, what remains inside is positive, and then we have the x, which is common between the two terms, plus R1 times R2 equal to 0. And now we can see what we have in this general expression is the following, that this x squared minus, if we look at this is actually just simply we are adding the two roots. So this is the sum of roots plus, and this part is simply the product of the two. So this is the product. So here product of roots equal to 0. So this is the general formula that you can use it to solve directly without having actually to follow these steps. You can find directly the quadratic equation. So if we want to apply this to the previous case, we have 2 and minus 3. If you add them, you will get minus 1. And then here minus 1, that give you 1. So we'll get plus x. And then the product of them, 2 times 3, that give you minus 6. So in place of the product, you will get minus 6. That will give us exactly the same thing that we get here. So now let's illustrate this with another example. Let's say you have quadratic equation with one root. Remember, a quadratic equation can have two real roots, it can have one real root, or it can have no real roots. In other words, it have a complex roots. So this is the case when you have one real root. So how should we solve this? We can apply the same thing, but in that case, just keep in mind that whenever you have a single root, you can treat them as a repeated root. So you have like 3 and 3. Then our quadratic equation will be the sum is 3 plus 3x plus the product 3 times 3 equal to 0. So this give you this give you x squared minus 6x plus 9 equal to 0. So this is the final answer to this question. Now let's also consider a quadratic equation with roots 1 plus minus 2i. So this is a case when there is no real roots. The roots are complex. Again, we can apply the same formula and it will work. So x squared minus the sum. So the two roots is 1 plus 2i. This is one root plus the other one, 1 minus 2i x plus the product. So 1 plus 2i times 1 minus 2i equal to 0. And then you will have x squared. You can see you have two terms that they are the same but with different signs. So this is plus 2i and this is negative 2i. These will cancel with each other, and then we will have 1 plus 1, 2. So we'll have 2x plus. Now to multiply this, notice this is of the following form: a minus b times a plus b. And you know that whenever you have something like this, it will be a squared minus b squared. Of course, if you don't remember this, you can just do it as we normally expand. So a times a, then a times b minus b times a, and then you will see that the middle terms cancel and you are left with this. So then let's use this shortcut to multiply these two terms. Then you will have the a in this case is 1, so you'll get 1 squared minus the b in this case is 2i, so you will have 2i squared equals to 0. And then you will have x squared minus 2x plus 1 minus, when we square the 2, you will get 4. And when you square I square is actually minus 1. So you'll get minus 1 equals to 0. And then you have x squared minus 2x, here 1. And minus with minus give you plus. So you will get 1 plus 4, that is 5 equals to 0. And this will be the quadratic equation whose roots are equal to 1 plus minus 2i. Okay, so let's take another example. Okay, so this example, we have one of the roots of quadratic equation with rational coefficient is 2 plus 3 square root of 5. So this may look similar to the previous example that we did, which we did here. So a quadratic equation with one root 3. However, there is a difference. Here we are told that the quadratic equation have one root. So one root for a quadratic equation means it's a repeated root actually. And to solve this kind of problem, it was simple. What you do is to treat it as a problem with two roots that have the same value. So if the given root is 3, you solve it as if the two roots are 3 and 3. If the given root is 4, you solve it as if the roots are 4 and 4. So that was straightforward. The new problem is different because it say that one of the roots. So it's not that the equation have one root. No, this is one of its roots is this one. So how to solve this kind of problem? To solve this, we need to figure out what is the other root. And to do that, let's remember something about the quadratic equation. So we know that for a quadratic equation, if the coefficients a, b, and c are all rational, and remember rational mean we can write it as a fraction. So 3 is rational because we can write it 3 over 1, 2 over 3, 3 over 4, and so on. These are rational numbers. So if these a, b, and c are rational, and we know that one of the roots is of the form m plus n square root of l. Then the other one is the conjugate, which is m minus n square root of l. So based on this, we know that the other root is 2 minus 3 square root of 5. Now, by knowing these two roots, then it will be easy to solve this. We need just to get the sum. The sum 2 plus 2 give you 4. Then you have plus 3 square root of 5 and minus 3 square root of 5. These are the same but with different signs, so they will cancel each other. Then the product. So you'll have 2 plus 3 square root of 5 times 2 minus 3 square root of 5. And we can multiply this easily just using the same expansion that we have here. So it will be a square minus b square. So we'll have the a in this case is 2 square and minus the b is 3 square root of 5 square. 2 square is 4. This is a 3 square root of 5 all square. So we can square each separately. 3 square will give you 9 times the square root of 5. When you square it, you will get rid of the square root. So you'll get 5. And this will give you 4 minus 45 will give you minus 41. So then our quadratic equation will be x squared minus the sum 4x plus the product, and the product in this case is minus 41. So plus and minus, that will give you minus. So you get minus 41 equal to 0. And this is the required solution. Now let's look at another example. This example is very important. We'll use it to illustrate a very, very important point. So pay attention. Now let's say the roots square root of 2 and 2 square root of 2. So to solve it, we follow the usual procedure. The sum, you have square root and 2 square root. So square root will be a common factor. So 1 plus 2 will give you 3. 3 square root of 2. Then the product, we have square root of 2 times 2 square root of 2. This is equal to square root times square root. The square root will cancel. So then you will have 2 times this 2 from here. That give you 4. And so the equation is x squared minus the sum, which is 3 square root 2x plus the product 4 equal to 0. And this is the solution. Now, the important point here is the following. Let's say that you know that one of the root was square root of 2. You may say, okay, then the other one should be minus square root of 2. Because this is what we said in the previous example. We said we have 2 plus 3 square root of 5. So the other root is 2 minus 3 square root of 5. Remember, we changed the sign of the bar that contained the square root. Now, by the same reasoning, this will look like something that we can do. We have a square root and then I get the other one by adding a minus sign. However, this example illustrates something that I already have this equation which have one root square root of 2 and the other root is 2 square root of 2, not this one. So what is the catch here? The key thing to keep in mind is the following, that to use this trick to find the other root, the coefficient should be rational. If the coefficients are not rational, you cannot make this conclusion. You can see that the final equation that we have irrational coefficient. The coefficient is not rational. I cannot write this as a fraction. So you can see there is square root of 2. the coefficient is irrational. So equation that have irrational coefficient, you may end up with irrational roots that are not conjugate. So that keep in mind. If the coefficient are rational, then you can make such a conclusion that the irrational roots are conjugate. Otherwise, you cannot. So finally, if you find this video useful, please give it a like and also consider subscribing to the channel and turn the notification on so that you get notified about new content. Thank you for watching.